Hello and most welcome to 1539 of the series. We are presently enjoying sunny weather. Finally. May hasn't been a very warm month here in Sweden, but now it's coming some sort of warmth, at least in the sun and in this rather protected area. An unusually cold spring so far. I think it's so interesting with Nicolas Gisin and his most recent development within science, mathematics, physics, and of course philosophy or thinking as such. I'm pressing that thinking will change with this understanding. It's a bit more than a minor glitch in the protocol. It's rather advanced. I will continue with this article. Does time really flow? New clues from a century-old approach to math. It's from Quantum magazine. And we just discussed how everything turns about depending on what sort of mathematics we are using. The Platonic existence math brings out a stillborn universe where everything, almost like an absurdly correct DNA structure, is decided from the very beginning without any deviations or surprises. It will most definitely develop that way. No deviations will happen. It is sort of decided in advance. A reality without development. A reality where the initial decision decides everything. The Big Bang, in this view, decides everything. There is no leeway, no surprises. Nothing can happen in this fixated worldview. We are not free to think even, because our thinking is also decided of what happened in the beginning. The Laplacian demon takes care of everything. Demon of Laplace. Using calculation, everything according to the original scheme can be accurately calculated, predicted. No longer is there any need for soul, human intention, want, will. It is sort of grayed out worldview. Most characteristically depicted as an aftermath after the happening that never happened. Oddly enough, it didn't really take place. And it's only for us to accept. Left with a omnious fact. What Nicolas Gisin is pointing to is that that picture comes from assumptions that we're not even aware we made. He reveals something that's been lying hidden for millennia. A tendency, or a bit more of a tendency, a whole gestalt of the world that hinders. It's getting too warm here. The wind suddenly. Sorry, I'm gonna put a pause here. And most of the absurd paradoxes that we covered in this series of almost 1530 episodes by now are caused by this unapproached gestalt. And how we as human beings gets locked in these paradoxes. Let me just mention a few. The homunculus, the view from nowhere, the homunculus being we do not really understand perception. It defies human understanding. And it leads to an infinite regress. Evermore regressing into the unknown infinities of further and further deepening. Of the problem. These are paradoxes that just cannot be resolved. Another one that we approach several times is the paradox of mind and matter. And now it gets warm again, cold again. It is also caused by this opposition. Because all of a sudden all matter becomes the predisposition for the soul or any thinking capacity. We no longer understand how two separated things can be connected. But the truth is, it's all a mistake or a misuse of language. The truth of the whole thing is from the original idea that everything is decided, erupts the problem of what is matter and what is mind. It never rises if we are firmly put into the picture from the very beginning. Another paradox is, of course, the origo and the coordinate system. Coordinate system becomes a replacer for deeper understanding and truer understanding. It blocks further understanding of any subject whatsoever, and we cannot delve into understanding deeper. And the fourth and maybe most important thing is, could there be a purpose to our lives? It's very hard to see any chance of free will in the scheme of the Platonic realities. Everything becomes unreal. Becomes an illusion, or it feels distanced, not in the reality. Unreal in a very definite way. And all the different solutions that have been proposed to save intention and will seem to be blocked or fixated on the idea that matter is everything and there is a supervenience on consciousness, or it emerges somewhere, and all of a sudden we have this hard problem of David Chalmers. A guess is that the understanding coming from Nicolas Gisin will solve this problem in an incredibly smooth way. What this revelation is almost a revelation, as revelatory standard, is also helping a lot with the problem we discussed from Lise Moulin and Roberto Unger in the book A Single Universe. We come to an understanding that the cosmological fallacy also develops from this idea, where all of a sudden knowledge can be outside the universe or outside ourselves. Something that clearly was shown to be wrong by understanding that information takes space. it is not non-spatial, it's demanding space. It needs to be situated somewhere. It cannot be in nowhere. And each piece of space can only have a limited amount of finite information. Not even a black hole has any possibility of carrying even one real number. Such is the limitation on the carrying capacity of space, or the immensity of a real number, no matter where it is. One way that infinity rears its head, I continue with the text, page 7, last paragraph. One way that infinity rears its head in quantum mechanics is in the tail problem. Try to localize a quantum system like an electron on the moon. And if you do that with standard mathematics, you have to admit that an electron on the moon has a super small probability of being also detected on Earth. Gisin said the tail of a mathematical function representing the particle's position becomes exponentially small but non-zero. But Gisin wonders, what reality should we attribute to a super small number? Most experimentalists would say, put it to 0 and stop questioning. But maybe the more theoretically oriented would say, okay, but there is something there according to the math. But it depends now with math, he continued. Classical math, there is something. In intuitionist math, nothing. No, there is nothing. The electron is on the moon, and its chance of turning up on Earth is well and truly 0. Since Gisin first published his work, the future has grown only more uncertain. Now, warm again, so now every day is a kind of Sunday for him, as crisis grips the world. Away from the lab and unable to see his granddaughters except on screen, he plans to keep thinking, at home with his mug of tea and garden view. And that concludes the article from Quantum Magazine about physicist Nicolas Gisin's recent work on intuitionism and the flow of time. I have done my best to explicate the philosophical and mathematical background to this subject for a non-technical audience. I find this topic to be a fascinating intersection of philosophical questions in the foundations of mathematics on the one hand, and our best understanding of the nature of physical reality on the other. It's a wonderful example of seemingly useless speculative ideas turning out to be profoundly useful in a future context. I will try to explicate myself just as the author here tried to explain to Quantum Magazine a bit more thoroughly, or for the audience of Quantum Magazine. Here we have anonymous writer on one of the forums, and I took the liberty to take out some of it to get a more grounded understanding of intuitionist mathematics and what it does to physics in this case. The intuitionist philosophy of mathematics was created by the mathematician Brouwer. He first articulated the ideas of his PhD dissertation in 1907 and continued to develop them for the rest of his life. In addition, many other mathematicians and philosophers developed Brouwer's ideas, so now there are intuitionist branches of math, logic, and philosophy of math. Brouwer's ideas were inspired by Kant's theory that mathematical knowledge originates in our perception of time. Brouwer's first big idea is about our ability to perceive that one moment in time gives way to another. Thus we have a 1 to 2 and the relationship between 1 and 2. Then in another moment we can relate this 2 moment to another moment, which we'll call 3. The key thing here is that these moments of subjective time perception and the experienced relationship of temporal flow between them are the real mathematical objects. Our symbols and language such as 1, 2, 3, plus and minus, etc. are just ways to talk about our experiences of temporally structured moments of reflection So we can understand the idea of an infinity of natural numbers by thinking of them as a sequence of reflection upon temporal moments that goes on and on without end. 1, 2, 3, 4, and so forth. For intuitionists, there are only potential infinities, not actual infinities. What that means is that we cannot regard an infinity as something that exists as a completed object, why it never exists fully at any moment in time. Instead, when we talk about an infinite set, like the set of all natural numbers, what we should mean is the temporal process that generates each natural number with no limit on how long it may continue to run. It is quite natural for me to think of this in terms of computer programming. It is easy to write a program that prints 1, 2, 3, 4 and keeps running to printing bigger and bigger numbers with no programmed stopping point. But does this mean I've generated an actual infinite set of numbers? Of course not. In finite time, my computer will only ever print out a certain finite subset of the natural numbers. The process is infinite only in the sense that it has no natural stopping point. We are not considering contingent stopping points, like my computer crashing or breaking down or losing power. In contrast to intuitionism, classical mathematics regards infinite sets as well-defined abstract objects. So the set of all natural numbers is a valid mathematical object that exists presently and in every moment, just as much as the numbers 1 or 2. Although this is a different philosophy, the actual mathematical implications of these philosophical differences are not very significant when dealing with natural numbers or integers or rational numbers, fractions. This is because in each of these cases the basic members of the infinite sets are not themselves infinite. In the set of naturals 1, 2, 3, each element can be produced through a finite terminating process. Similarly, every rational number can be expressed as a fraction, which is defined from integers. So the list of all rationals is still generated from elements we can construct in a finite amount of time. This means that for the most part we can treat math that is concerned with whole or fractional numbers pretty much the same way, whether we adopt an intuitionist viewpoint or a classical viewpoint. However, all that changes when we come to real numbers. In math, real numbers are used to describe things that change continuously, which includes almost everything that physics talks about. In geometry, the length of a line segment would be expressed as a real number. Yes, it would have an endless series of decimals. Sorry, just a comment here. There's a famous legend about how Pythagoras believed that every number could be expressed as fractions of whole numbers. And when his followers provided a demonstration that the hypotenuse of a triangle with bases of length 1 could not be expressed as a fraction, Pythagoras killed him on the spot for heresy. Thank God it's not a heresy anymore. The classical view of real numbers is that each real number is defined by an infinite set of digits. So for example, you can represent the real number 1 as 1.0000000 and so forth. The zeros go on forever. Why? Because suppose we just got lazy and said that for this real number we're only going to write 2 zeros. Then we could ask, is 1.00 greater or smaller than 1.001? Now, if we don't know what comes after the second zero, we can't answer this question. Now, if we don't know what comes after the second zero, we cannot answer the question. Do remember that. Here lies the most interesting thing for decades, I would say, within mathematics. But it turns out that it is very important for the concept of continuously changing quantity that there always be an answer to this question. A continuum requires a complete linear ordering of numbers. So therefore, in the classical view, the very nature of a real number is an infinite string of digits plus some scaling factors. That is where to put the decimal point. Okay, so now you might be starting to see why here the math starts to diverge more between the classical view and the intuitionistic view. For according to the intuitionistic view, a real number is not a thing, not a completed object at a given moment in time. Rather, it is a process. It is an expanding series of digits. Brouwer called this a choice sequence. He imagined a free agent who picked each next number in the sequence. The next number might be picked in a law-like way or in a non-law-like way. For example, I might decide to write down all the digits of pi, 3, 1, 4, 1, 5, 9, 2, 6, 5, 3, 5, 8, 9, 7, 9, and so forth. This is purely a law-like choice sequence. However, I also might write down the digits of pi for 20 digits and then just start picking random numbers. That is also a perfectly acceptable choice sequence to generate a real number. However, the crucial thing here is that we never really know what the next digit in the sequence will be until after the point in time when it gets chosen. There's nothing in the definition of a real number that says that all the digits have to be generated according to a mechanical rule of algorithm. There's no way to see into the future of the process of choosing digits to know in advance how things turns out. So for the intuitionist, mathematic reality itself is time relative. It takes time, it happens in time, and it happens because of time. And literally, it is time, I would say, my comments. After the digit has been chosen, the chooser can't go back on the choice, because doing so would just be to define a different real number. But before the next digit has been chosen, the reality of that digit and all subsequent ones is fundamentally open to multiple possibilities. Incidentally, this also accords well with the intuitionist theory of logic, which makes mathematical truth time relative. An intuitionist says that a statement like A or not A is neither true nor false at the point in time where we haven't proven either A or not A. In classical logic, as you know by now, the statement A or not A is logically true for any statement A, a tautology known as the law of the excluded middle. For the intuitionist, the law of the excluded middle is invalid. Now here you can remember the traffic light. It's time itself that makes for what is perceived from a non-real, non-temporal viewpoint as contradictions. Yet A or not A may, and this is important, become true at a later point in time, once we have produced a proof of one of the two sides. Clearly, we cannot prove facts about a real number as a certain infinite string of digits if some of those digits do not have a determinant value at this point in time. So the rules of intuitionist logic and the account of the essentially temporal nature of the numbers are mutually consistent. In contrast, classical mathematics, which has been used to develop all our current theories of physics, remember that, and all other subjects as well, they are all timeless, assumes that every real number possesses an infinite degree of precision at every moment in time, and this is so good. And this is consistent with classical logic's endorsement of of the law of the excluded middle. As a result of these differences in the nature of real numbers and other uncountable elements, many of the classical theorems in the mathematical field of analysis, also known as calculus, are actually false in an intuitionistic system. However, in most of these cases, there are alternative theorems that resemble the original theorems but replaces claims such as there exists such and such a real number with there exists arbitrarily precise approximations of such and such a real number. Replacing the idea of quantity as an actional infinity with the idea of the same quantity as an endless process that converges towards the quantity. And here there's a summary from the anonymous scribes to whom we are greatly indebtful. That's about as far as my understanding goes. What I took from the Quanta article is that these new physics papers are trying to replace the mathematically classical equations of relativity and quantum mechanics with analogous expressions expressed in the language of intuitionism. What this means on a physical level is that quantities like mass, position, charge, spin, etc. are never infinitely precise, and they become more precise as time moves forward. Since information itself is finite in the universe, there cannot be literal infinities for any physical quantity. Hooray, finally we put that on paper and as a marvelous quote as well. But as time moves forward, more information might be created at some determinate rate. This means that the flow of time has a real, potentially measurable physical effect. Previously, this was not thought to be the case for general relativity. Time was just a direction, no different from the spatial directions. Remember the orthogonal perpendicular coordinate system of Descartes and so forth, where arrows are needed to put in to give them an illusion, I would say, of a direction. Think of a particle existing at a position in space-time. You can describe that position with four numbers: x, y, z, t. If any of these numbers changes, the change in the number represent a change in the position of the particle. For instance, change in x is x1 minus x2. This implies that to change itself, the movement or flow from one position to another is not a physical thing above and beyond the facts captured by X, Y, Z, and T. This is why Einstein's universe is called a block universe. Every number that defines positions past, present, and future could exist eternally as a static mathematical description of the whole space-time continuum. However, once the equations are recast using intuitionist mathematics, the change in time is more than just a change in position coordinate. And that is because the change in time also increases the precision of every physical quantity, unfurling more digits across the universe. This makes time special and gives a measurable physical meaning to the idea that time flows. So this development comes as a savior of human existence, because the block universe is absolutely stagnant. Everything is fixed from the outset, that meaning that there is no knowledge to be gained. Point made by Friedrich Nietzsche in Gay Science and many of his other literary works. It also shows why so many thermodynamic scientists off themselves in the late 19th century, early 20th century, when the second law of thermodynamics were exposed, were put into letters and equations, where the universe seems to go because of the determination of the initial conditions to its own very death, something that obviously makes everything absolutely pointless. And I think Friedrich Nietzsche has another thing to add, that it also makes knowledge absolutely impossible, which is actually worse than the end of the universe. This is hope for humanity, because it shows that there is at bottom a mistake done. All science, all knowledge is based on this mistake. Yes, it's not a normal mistake, to be clear. It's a mistake that we've forgotten that things takes time, and that time produces the scribbles you make on a piece of paper that is mathematics. And that could be no order whatsoever without time. And that's why ordinal numbers are so helpful to explain why time is in mathematics, and there wouldn't be any mathematics without time. Realizing that and embracing the intuitionist logic and mathematics will show to you, and will show physics, biology, chemistry, all the subjects, when we take time into consideration, we gain exactitudeness, because only time can tell whether a number is larger or smaller than another one, if it's connected, if it's related, what is the sort of relation it has. It becomes more and more specific, but it's never the matter of either or. The law of the excluded middle is a mistake, but the background for this mistake is it's harder to fathom than one initially understands. It's a forgetfulness of that once you learn these things, you start forgetting it took time. A small child wouldn't do it. You need to be complex enough to forget it took time, and then you can do the mistake. Well, hopeful news on the mathematical and the physical front and all other fronts of human knowledge. I say thank you very much to the author, the unknown author. We are forever indebted to you. See if I can't find your name to put it into the description. It wasn't directly in the blog. And I wish you all a very pleasant night. It's just night, 7 o'clock. Bye bye for now, and thank you.